Hello everybody, I'm going to show you about queues today in computer science. So, imagine that you have a bridge and you have three processes that need to occur, or three operations that need to occur. There's a lot of ways to use a queue, and we can go into that later. But first, just imagine this. So, all of these processes need to perform this operation or need to access this structure, and when they've completed that, they'll be on the other side. So the first process may begin the operation. Now the next process will go right after it and then right after it. So as you can tell, the first one that crosses the bridge, the first one that enters the bridge will be the first one that crosses the bridge. They call that first in, first out, FIFO. Now, you may get a situation where you want to break that construct. Well, the bridge is kind of an explanation for that. So if another one wants to get on there, we have to break the construct in order to get out first. Oh no! Now, there's another way to assemble this, and that is that you could have a priority queue, in which case, if we have priority 1, 2, and 3, where 1 is the highest priority and 3 is the lowest priority, well then if you have, say, priority 2 and priority 1 needs to get across the bridge, they could both be lined up in the queue, but the construct will allow for the highest priority to come out first. And then if you have two that are of equal priority, then it's the first in that would be the first out, and then everything has crossed that bridge. So that's kind of the simple explanation for a queue system, and now I'm going to show it to you a little bit differently. All right, thank you. All right, so showing it to you in code. Queues in .NET, people typically don't build a new queue structure. They use a queue structure that .NET's already provided with their libraries, because they can do they have a generic queue. Same thing with stacks, but the generic queue can take in delegates to functions as well as just basic data types. So I could have a queue of integers or strings or characters, something of that nature. But I also could have a queue of functions that get passed in as delegates, actions, funcs. There's a couple different types of delegates that come out of the box with C# as well, tasks. And as they go into this queue system, you could perform an action that needs to wait on another action. But a lot of times when you see queues is when you have web services or microservices. So you got a request that comes into your microservice, it gets placed in a queue, and then you start listing for more requests to come in, so you can keep that operation flowing quickly. And your queue can get processed with either another thread or at another time, and you can make sure that these functions happen in the order that they're supposed to happen. Anyways, so looking at some code I put together for you, we're not using the built-in queue system, even though that one's much better. This will give you a better picture of how the queue works. So I created a queue class here, and I'll just go through it with you. So right out the gate, I created a few integers. Capacity, since I'm building this queue as an array, and then we've got rear and front. Front's not really needed, it's just more of a conceptual thing. Front's always 0 because we're always at the front of the array. Data comes in at the back of the array, leaves out the front. So the rear of the array, the pointer to that, will keep moving to the left or to a higher indice within the array as we add items, and it'll move closer to the front as we remove items. So it'll be at 0 when there's nothing in it, and it'll move as we add things. I've made my particular queue is going to be an array of integers. That means every item in the queue is an integer. We've got our constructor where we set the capacity. How many items at most can we have in the queue at any given time? And so we'll get that value, assign it to our property in the constructor, and then we declare the queue itself here of integers, but you also have to implement it, give it a size here. And then if we go over to our program, I enqueue 5 items, and then I dequeue 5 items. So first, the enqueue method, the item that gets sent in, and we're saying if the queue is already full, if the rear pointer is already at the end of the array size, then we can't add anything. Otherwise, we can go ahead and add it to the array at the last position, that the first position that has nothing in it, and then we increment our pointer to move that position further out towards the capacity. Now DQ, let's see, I DQ them here. Now the DQ is going to return an integer, whereas NQ returns nothing. It's just putting something on the array. DQ, it returns an integer, but it takes nothing. And we're saying if you can't put anything in it because we've defined it as a 0 size array, or if there's nothing that's been added to it yet, either way we can't return anything. Depending on the purpose of you building this queue, you might be able to get away with just returning 0 or -1. Otherwise, you might need to throw an exception. You could do throw new exception, bad input, something along that line. All right, so I take, in my implementation, there are many ways to do it, but I take the item to return off the front and store it in a temporary variable. That way I can shift everything over in the array by 1. Then once we've shifted everything over, you'll have a copy on the left or on the highest indices side of the array where the data was. You'll have a copy of it. So if you shift everything, let's say it was 9, 5, 7, and you shift it over because you popped 7 off, you DQ'd 7, now you have 9 and 5, you'll see 9, 9, 5 because we copied it. So I set that first 9 to 0, and we'll do that here. And then we want to decrement rear so that we know that we can again add to the position where the 9 was, or where that last element was that we removed. So since we're adding to the front, or adding to the rear, removing from the front, you want that rear position to move. Let's go ahead and step through it so you can see how this works in action. I'm going to hit F5. Oh, actually, let's set a breakpoint here and hit F5. So you can see my queue right now has capacity 5 that we set in the initialization when we hit the constructor. The front is always 0, just kind of a reminder where that pointer is. And the rear right now is at 5. It's at max capacity. We can't add anything to 5. That's why we reference rear -1, because you remember arrays go from 0 to length -1. And now if I expand the queue, you can see 1, 3, 5, 7, 9, all in the same order that we queued them. So if I DQ 2 of them, you will see we're now down to 3 position for the rear. And those 2 items have been set to 0. So they're no longer in there. And these have been shifted to the front, or are still at the front. So if I take them all off of there, now it's going to be capacity still 5, but the front and rear both set to 0, and the queue has only zeros in it. So if I hit F5 to do that read line to get it on the screen, you'll see 1, 3, 5, 7, 9, just the same as the order that I put them in. That's really all there is to it. Queues are really straightforward, and they're used in so many different applications. I know you probably won't usually have queues of integers. There'll be queues of processes, and there are actually some applications out there that you can use that help you with your queues to separate them from your development application, just to kind of keep them running entirely separate. You might even have a server dedicated to that queue. Some of them are Windows services. Some of them are developed in other technologies. So feel free to look into that, and have a great day. That's queues. Bye.